Welcome to section 2, making the Hadoop efficient yarn architecture. And this section is going to be very interesting and where we're going to talk about many things, guys. In this whole section, we're going to talk about what is resource manager and how the rise of resource manager happened. We talk about yarn architecture. We talk about how yarn has effectively increased the potential of Hadoop. We'll check out the differences of classic Hadoop and then yarn architecture of Hadoop. We talk about yarn daemons, containers. We talk about speculative execution. We also talk about HDFS federation, and then we'll talk about the important features of Hadoop, authentication and high availability, and the most important thing over here, which is understanding the differences between Hadoop 1.x, 2.x and 3.x. So we'll understand all those changes in our upcoming videos. First of all, we'll pick up the first video of it, which is Rise of Resource Manager. In this video, we are going to take a look at overall look of Hadoop 1.x version. We'll talk about what is job tracker, what is task tracker, and then anatomy of Hadoop 1.x, and then we'll talk about the problems with Hadoop version 1. What are the problems with NameNode failure, and then we talk about the drawbacks. Then we talk about the resource manager, how and why a particular resource manager, and what this resource manager is all about. Take a look at all these concepts over here. So this is the whole look. Now we are actually zooming into the whole section over here, and you can see that this is my whole Hadoop system, right? Hadoop version 1, where you have a master node and you have a slave node. Now you can notice over here in master node I have something which is new, right, which is called job tracker, and we have slave node which we have where we have something called as task tracker, which was not there, which we haven't explored in the last videos. So these job tracker and task tracker are nothing but, now over here you might have noticed that if you want to deal with some kind of systematic thing or distributed thing where the data is actually scattered completely, then it's very much essential for us to have a track of every information, where the data is going, how much data has been completed, and all that information. Now to understand this, right, we need to zoom into this, and we need to understand what is this job tracker and task tracker. Over here the job tracker is the master daemon and task tracker is my slave daemon, right? And what these daemons are, right, you must be wondering what is that daemon word, right? What does that daemon do over here? The daemons are nothing but the services which are running in the background. They are essentially programs and services which are running in the background. So I have a master service which is job tracker. I have a slave service which is task tracker, which actually is being given into the slave node so that it can actually functions well. So now this job tracker is actually creating a lot of problem while initiating the monitoring and recreation of the jobs. And we need to understand how a job has been completed. Right now we need to understand there is one service which is a master service, which actually keeps on getting requests from different master services like clients, and then you have a task tracker which actually runs a lot of services and a lot of tasks together. So let's understand what is this job tracker. Job tracker processes runs on a separate node and not usually on a data node, and this job tracker is an essential daemon for MapReduce execution in MRV1, which is MapReduce version 1. Job tracker receives the request for MapReduce execution from client. Job tracker talks to NameNode to determine the location of the data. And if you remember from the previous video, we were talking about how client talks to the NameNode, right? So job tracker actually come in between and talks to NameNode service and asks for the location of the data, where this location will be, where the data will be stored for the future jobs. Now what it does is it actually finds the best task tracker which needs to execute a job and data locality. Basically it just says that I want my data to be on the nearest node, and I just wanted to have the available slot to execute a particular task on a particular node. Job tracker also monitors the individual task tracker and then submits back the overall status of the job back to the client. Job tracker processes is critical to Hadoop cluster in terms of MapReduce execution. And when a job tracker is down, HDFS will still be functional, but the MapReduce execution cannot be started, and the existing MapReduce job will be halted because the existing job will not know any kind of connection between the data node and the master node. Job tracker is actually in touch with TaskTracker and then keeps on getting the updates from the NameNode know that this job is particularly running. If job tracker is down, the data nodes are not down, they keep on working, but it will not be able to execute the job properly because they don't know what kind of job and what status of the job is. Now we talk about the TaskTracker. TaskTracker runs on data nodes. It's actually on every data node. So every data node will have one TaskTracker, and in future you will see that this TaskTracker is nothing but a node manager in the upcoming version, but for now we understand that it is TaskTracker. And then mappers and reducer tasks are executed on data node administrated by TaskTracker. So you can say that TaskTracker is the guy who is managing the whole data node. This TaskTracker will be assigned the mappers and reducer task executed by job tracker. So job tracker says, you know what, they just run these mappers and reducer task. Reducing is nothing but the aggregation. We remember that from the last video, and then it actually runs the whole. The task tracker will be constant communication with job tracker, signaling the progress of task in execution. The task tracker failure is not considered as fatal. When a task tracker becomes unresponsive, job tracker will assign that task executed by job tracker to another node, which means that task tracker keeps on giving updates to job tracker saying that, okay, I have done 50%, I have done 60%, I have done 70%, and so on and so forth, and actually keeps on informing that to job tracker. But the moment TaskTracker is down, it doesn't mean that your complete Hadoop is down. It means that a particular data node is down, which means that what you're going to do is you're going to assign that task to a different task manager altogether. And you say that, you know what, my one data node is down. Why don't you pick up this task and start working on it? So your different data node will, different data node and different task tracker will pick up that particular job and start working on that. That's how this task tracker and job tracker coordinates. Now if you just look at the whole architecture, you can see that now we're zooming in, guys. So we can see that every job tracker is having two components. One is map and the second is reduce, and it just keeps on picking up the data, right? And then you have a job tracker which actually determines the execution plan of how a particular job will be executed and give that information to task tracker so that task tracker can actually perform that. On the top of that, you can see that we have NameNode, which just keeps information about file name, location information, and all those stuff. And what client says, I have this data, right? And I have this XML file and I have this jar file. And this jar file is nothing but the output of a Java file, right? So if you have created a Java program, you can convert that into a jar, and this jar file have all the instructions written down into it, and these instructions are required in order to run the job, right? So for example, I have some data, I want to do something in that data. I will write down all that information in that jar file, and I will let this NameNode know that, hey NameNode, I have this much of data and this is my jar file, please execute this job for me. And then NameNode will actually come up with the location. Okay, keep this location, just take this location from me and go to that data node and store your data over there. And all this information will be passed on to data node, and data node will perform the MapReduce task for you, and you will get eventually the output. And once that the task tracker notifies that job tracker that job has been completed, job tracker sends a message to client that, hey client, your job has been completed, why don't you go to this data node and pick up the output from there, which is being stored in that a particular data node. And client actually goes to that particular data node and picks up the output from there. That's how the whole Hadoop works. Alright, so now we understood the anatomy of Hadoop, right, completely. Now we have a clear-cut understanding of what exactly is been happening in Hadoop 1.0. We're going to talk about problems which Hadoop version 1 was having. First thing first, it's availability issue. One single point of availability. Hadoop was not accessible through multiple channels. It was accessible only through one master daemon, and that was one of the problem. Scalability issue, that like if you have one machine which is actually doing a lot of tasks like monitoring, job scheduling, task scheduling, management, which is your master node machine. And that's where actually a bottleneck has been created, that you cannot increase the number of data nodes after a certain number, because a lot of data needs to be accumulated into NameNode memory so that it can just pick up all the tasks. So if you keep on increasing the number of data nodes, then metadata will be increased in NameNode's memory, and that's where it becomes challenging. Now, a cascade failure issue, only 4000 nodes is being observed that beyond 4000 nodes Hadoop version 1 is not responsive at all. Multi-tenancy issue, multiple jobs. You cannot run multiple jobs in the Hadoop version 1 because there are like only one machine to handle the whole resource. And that's where, if you just notice that it's actually an insufficient utilization of resource, because not all the data nodes are working at the same point in time. Some of the data nodes are working, which receives the data, some of them are not working, which means that we are not actually optimizing the whole Hadoop system. So coming to that, we have got some more issue, right? In case NameNode fails, right? What was the problem? It was a single point of failure. Transaction logs are stored in multiple directories and couldn't be accessed if NameNode fails. Directory will be there on the local file system, couldn't be accessible, and directory of a remote file system, NFS directory, will not be accessible. And people really wanted to develop a real high availability solution, which means that if even in NameNode fails, the Hadoop shouldn't be stopped. So there were a lot of challenges for, like, if people wanted to do that. And then NameNode, it was not at all backed up by standby system, which means that because secondary NameNode was picking up the periodic backup from NameNode, say for example, say just right now secondary NameNode picked up the backup, and after a while you realize that half an hour later the primary NameNode is down. So secondary NameNode doesn't have a chance to pick up any of the information from there, and that's where the problem arises. So NameNode needs to be backed up every time, and that means we need to have a hot standby system which can just pick up the data and keeps on working every second, so that any of the information loss is not there. And then we talked about the second point as well. Secondary NameNode was not at all the hard standby. It was hourly backing up the data. In case of primary NameNode failure, entire cluster become inaccessible, and we have data and information loss both. And the namespace are limited to 1 with no horizontal scalability. That means we couldn't increase the availability of or horizontal scalability of NameNode. You can understand like what was the problem in Hadoop version 1 and how we can resolve it. Now this whole problem is being resolved via one solution, right? And you can see that on the left hand side I have Hadoop version 1, which is having MapReduce, which is cluster resource management and data processing, and Hadoop distributed file system. And on the other hand, on the right hand side, we have MapReduce and other data processing, and then we have HDFS, which is completely below. And there is one term which is called as YAN, and it's known as yet another resource negotiator. And this yet another resource negotiator is actually sandwiched between MapReduce and HDFS, and this layer in between is responsible for cluster resource management and data processing. Right, so this is our resource manager, guys, who is actually handling the whole issue completely, and all the issues are completely gone.